press the bell icon on the YouTube app and never miss another update.
Hi students, so in exercise 10.5, so far we have completed 7 problems. Now I will take up the 8th one. So exercise 10.5, question number 8. Please open your textbook, page 185. If the non-parallel sides of a trapezium are equal, prove that it is cyclic. So, for this figure is not given in the textbook, we have to prepare the sketch. So, in such problems, we have to be very careful in drawing the sketches. So, what is given is ABCD is a trapezium, and we know that AB and DC are the parallel sides. So, when a pair of parallel sides are there in a quadrilateral, then we call it as a trapezium. In this case, he says if the non-parallel sides of a trapezium are equal, that means AD equals BC. AD equals BC. When such a condition is there, we have to prove that the trapezium is cyclic. So, that means a circle passes through all the 4 points. That is what we have to prove. So, for that what we have to do is, we have to prove that either A plus C is equal to 180, or D plus B is 180. Because in any quadrilateral, if the opposite angles sum up to 180 degree, that means if they are supplementary, then the quadrilateral will be cyclic. So, that is how we move with this. So, now given trapezium ABCD, where AD is equal to BC, non-parallel sides. Or equal in length. Now, see, because ABCD is a trapezium, we have AB parallel to DC. AB parallel to DC. Now, construction. Draw AM perpendicular to DC, AM perpendicular to DC and BN perpendicular to DC. See, because AB is parallel to DC, the perpendicular distance between these two lines, that is AN and BN. So, therefore, AM will be equal to BN, because perpendicular distance between two parallel lines is always same. So, now with this, to prove ABCD is cyclic. ABCD is cyclic. This is what we have to prove. Now, proof. So, you observe these two small triangles AMD and BNC. Compare those two triangles. So, compare AMD and BNC, triangle BNC. So, in these two triangles, if you observe, AD is equal to BC given. It is given. Now, so this side is equal to this side. AM equals BN. Both are perpendicular distances. It is here only. AM equals BN. So, perpendicular distance between parallel lines. Between parallel lines. So, therefore, they are equal. Now, AMD, angle AMD is equal to angle BNC is equal to 90 degree. It is by construction. By construction. Now, with this data, we can say by RHS congruence. So, therefore, by RHS, this is hypotenuse, right angle and one side, RHS congruence. RHS congruence, these two triangles are congruent. So, AMD, triangle AMD congruent to triangle BNC. BNC. So, we have proved that these two small triangles, they are congruent to each other. Now, I will erase the earlier portion and I will continue from the top. Now, see, because these two triangles are congruent, we can say DM is equal to NC. DM is equal to NC. This is equal to this by CPCT, by corresponding parts of congruent circles, by CPCT. So, not only that, we have ADM angle is equal to CNB angle. So, this is also by CPCT, corresponding parts of congruent triangles. So, we have proved that this angle is equal to this angle. Now, you observe here ADM is same as ADC. So, therefore, this implies, I will write ADM is nothing but ADC, ADM is nothing but ADC, and also CNB you can see, BCN, sorry, this is BCN. So, BCN is same as BCD. So, if we call BCN, this is the angle. If we call BCD, the same angle. Now, So from this we have come to this. Let us call this as equation 1. Now observe, we have AB parallel to DC. AB parallel to DC. So consider this is parallel to this. Consider AD transversal. AD transversal. AD transversal. So therefore what happens? See, the angle BAD, this total angle BAD. So therefore BAD angle plus ADC angle. So this angle and this angle, they become interior consecutive. So that is ADC, BAD and ADC. So sum of these two must be equal to 180 degree. Reason is interior consecutive. Interior consecutive. Now see ADC, observe from 1, ADC is nothing but BCD. So here instead of ADC you substitute BDC. So therefore substitute ADC equals, see, BCD. So this value you take here. So therefore BAD plus, instead of ADC I will write BCD. BCD is equal to 180 degree. Now observe these two angles. BAD is this angle, and BCD is this angle. That means we have proved that the sum of the opposite angles is 180 degree. So this shows sum of opposite angles is 180 degree. So in any quadrilateral, if sum of the opposite angle is 180 degree, then the quadrilateral is cyclic. So therefore ABCD is cyclic. ABCD is cyclic, hence proved. So this completes question number 8. So now I move on to next question, question number 9. Question number 9. Let us read the question number 9. two circles intersect at 2 points B and C. So let us draw the diagram first pertaining to question number 9. Takes a lot of time. Please be patient. So these are two circles. And the question says that they are intersecting at point B and C. This is point B and this is point C. Point C. Now, through B, two line segments ABD and PBQ are drawn to intersect the circles at AD and BC. So we have two lines ABD. This is A, this is D. And one more line from here, and this is PQ. PQ. Now, CQ and CP. Join CQ. Join CP. CA, join CA. So this is the diagram. The diagram is given in the textbook. Now the question is, prove that ACP is equal to QCD. ACP. So we have to prove that this angle CQD, D we have to join, because we have to find this. So we have to prove that these two angles are equal. This is the question. Now, so given two circles intersect at B and C. So point B at point C, circles are intersecting. So line segments ABD and PBQ. Intersecting circles at A, D and PQ respectively. So, to prove these two angles, ACP is equal to QCD. Angle ACP is equal to QCD. So, these two are equal, that we have to prove. Construction. Join AP. This is the construction. I will show in dotted lines. This is for our convenience. And DQ. Simple construction. Join AP and DQ. Chords. So, they are now chords. Now, proof. Consider chord AP. Considering chord AP, observe this, when AP is considered as the chord, the angles APB and PBA, those two are angles in the same segment. So, we can say PBA is equal to ACP. So, reason is angles in the same segment, subtended by a chord, same segment, angles in the same segment. Now, similarly, you consider chord DQ. So, consider chord DQ. So, when you take up that, you can see the figure. DBQ angle will be equal to DBQ angle will be equal to QCD. The reason is same, angles in the same segment. Subtended by a chord DQ, same segment, angles in the same segment. Now, you can call this as equation 1 and this as equation 2. See what we have, in simple terms, if I call this as 1 and this as 2 and this angle as 3 and this angle as 4. So far what we have done, we have shown that 1 is equal to 2 and 3 is equal to 4. Now you observe the figure, 1 and 3 are vertically opposite. So therefore 1 is equal to 3. So I will take up that here. From figure, so what is 1 in our case? That is PBA. PBA equals that is DBQ. DBQ. Reason is vertically opposite. See, 1 is equal to 2, 3 is equal to 4, and also we have proved 1 is equal to 3. So therefore 2 is equal to 4. So that is the logic. So this is, I will call this as 3. So therefore from 1, 2 and 3, see, ACP angle, this angle is equal to QCD. So this is what we are asked to prove. So this is 2 equals 4. Note down please.